good afternoon, and good evening to everybody who's joining us, depending on where you are in the world. My name is Bradley Forder. I'm Head of Communications at the World Steel Association here. I'm filling in for your normal host, Andrew Purvis, who is the Director of Sustainable Manufacturing, on what is the third of this special safety webinars that we're running in collaboration with Draeger. Before I hand over to the studio there in Lübeck, which we can all see on our screens, I think, just a few opening comments from me on safety in general at World Steel and why it is that we're having a webinar in the first place on this specific topic. To deal with the first of those points, I'd like to stress that it is the explicit commitment of the World Steel Board of Members that safety and health is the #1 priority of the industry globally. The lost time injury frequency rate, which we define as the number of injuries sustained that prevents a worker or contractor from carrying out their next scheduled shift, 10 years ago was 1.63. Last year, the year for which we have the most recent data available, was 0.65. So the steel industry is getting safer gradually, but we're not yet at our goal of zero harm, which is the explicit commitment that World Steel members make. Part of the reason for having this webinar is raising awareness of that general commitment and the issues specifically in terms of risks posed by working in the steel industry, gassing and asphyxiation that we're focusing on today being an important one of them. In fact, over the last 10 years, that cause of fatalities, in fact, accounted for 72 fatalities. And we had 4 fatalities last year, according to our data, in 2022. That makes gassing asphyxiation the 5th most common cause of fatality in the steel industry. But in fact, in terms of the ratio with lost time injuries and fatalities, it's actually the most serious cause of fatalities in the industry. That is to say that it doesn't happen as frequently as other causes of injury does happen, but when an incident involving gas does happen in the steel industry, it tends to be the most fatal. So on that sobering note, I'll hand over to our friends at Draeger, who will talk to us about safe operations in confined spaces with respect to that topic. So Lübeck, over to you. Thank you.
Thank you, Bradley. And do you hear me? Is the sound?
Yes. I can hear you. That's yes.
Yes. Oh, perfect. So also from our side, a warm welcome to the topic safe operation in confined spaces. This is module 3 from 5, and we had the modules before. The first one was risk assessment, and the second one was explosive gas atmospheres. And now the topic safe operations. And this topic was also last year from 3M. They have looked more at falling or working at heights. And we have here our focus, safe operation in confined spaces. This includes also clearance measurement and so on. You will see when we go further on. Short point, my name Thomas Lawrence. I'm the global trainer for occupational health and safety and confined space entry, and also personal protecting equipment, and also part of hygienic work parts. This is my part in the global academy, and I have René.
Thank you, Thomas. My name is René, and I'm taking care of the mobile gas measurement and the product management, and I'm responsible for 2 product groups for the electrochemical sensors in our mobile gas detections, which we want to focus on a few slides later, and also on one special gas measurement device. It's called XPIT. Yeah.
You will see we have some nice news for you and a little bit introduction about our company. We have more than 60,000 employees. And net sales, you see in Europe, how many million? And our chairman of the executive board is Stefan Dreger, and it's a family-hand company. And you see also our business organization, typical German one. And our headquarter is in Lübeck here. And you see we have also different production sites. You see we have a lot of countries worldwide where we produce our equipment. And sales and service location we have in here you see 50 countries, and one of these will be close to you when you want to look for more information about sales and service. Here a little overview about our headquarters. What we have seen only in written words here with nice dots. You see we have also different colors on these, and you see we are global. And you see someone is close to you in your area. Our agenda, we will start with confined spaces, and you see hazards and risk. You will see we have some more as only one. Then we have a little slide about accidents and incidents. This is one from the NIOSH side. I want to show here that you have also to look for different injuries for rescue and so on. So it's a short one about these. And then we have module 3. This is then our gas measuring and clearance measuring and monitoring. It's also an important point. So far, then we can start with our first topic, confined spaces, hazards, and risk. We will start with a little bit basics about confined spaces so that we all will be committed what is confined space. This is our slide for these. So a little question about, and this is a little bit preparing about confined spaces. What is now a confined space? Have you sitting in a confined space? So wait a moment. You will see after these pictures a little confined space. But we have to talk about which topics we have of confined space. You see here, when I lay in some containers or something like this, you will see I enter confined spaces. And also in the middle is a press, as example. There can also be some gases or hazards inside. Or on the other picture is he enter with his head in the confined space. But on the further side he works, it's not directly in a confined space. But you can see on the edge of this side that his head will be enter in a confined space. It's the same like on this job, when he lift higher up with his head, he will also enter in a confined space. Next topic can be this free one. You know this as example from waste and water, or also from other drains and so on. And here we have a picture between us, and you see typical waste and water part, but you will have this on your company plans. So we have here also some waste and water, so familiar one. And from the manufacturer side, as example, when you will be in a tube or something like this, it's also part of confined spaces. And as example, you dig a hole or something like this, and you see this can also be a confined space when he starts welding or other things, as example. So a little overview gives some more, but I think this were some typical ones. And now you will sit in a confined space. So the definition of a confined space, you see, it's a complete or particular confined space, enclosed space. So it's fully mounted and so on. But the important thing here is for confined space, when you have the discussion about, the important point is not primarily designed for human occupancy. This is one of the important things when you think about, is this now a confined space or not? So it's not designed for the human being as a normal work environment. So this is the main part. What can be in the confined space? We can have some
toxic air, for example, or we can have a hole in on the top of the confined space where we can enter, and inside of the confined space, as you see on our picture, they can be every type of liquids, hazard gases, whatever you can imagine, because remember, usually that's a production site and we have some products in it and they could be dangerous also if they are empty or cleaned, but the rest of them will be always there, like you can see on the right side of the screen.
So now we have put in some birds on top. So we have seen, we have opened the lid, and what think the birds at first? So the old measurement from the mining, as example, was with these nice birds, only for an information. So this will say, this is not my part. The other bird said also, I will fly away. The other one has think too long and falls in the confined space. Can we now go further in to get out these little bird? No, think about it. Eric PD or stop, it depends, part of ISO 45001. And think about it's a trap. Confined space permitted only by permit as example, and you have to calculate the risk and have to do the safety parts. And definition of confined space is the first one.
For example, if you have less oxygen, then there's a dangerous atmosphere and you can't breathe, for example.
The second one is explosive atmosphere.
And the third one, toxic gases and materials. So if you inhale them, you could die or whatever.
So you see this were the characteristic three ones, ox, X, tox. So yes, some guys said it's X, ox, tox, but we have changed this in ox, X, tox so that we have speak about it. This is the three important things of confined space. But a lot of people forgot number 4. And number 4 is attention about other hazards when we work in confined spaces.
And there are a lot of them. As you can see in our slide, the first one, or one of the most important one, is injuries caused by falling. Like you heard last year, working in heights and so on, there's always the possibility that you can fall when you want to enter or when you work at different heights. There could be the danger that you are falling.
And you can also have some radiation. It's a bit special, but can happen that also things like this will be in. So you can't taste it, you can't smell it. It's the same like carcinogenic ones. You can also taste it or smell it. Or crashed by
a loud noise. That's some of the most important things in my point of view, because think about it. You are surrounded by steel and every noise is so much louder than you have it in the surrounding area where no steel is around you. So that's much, much louder than you can imagine.
Yeah, and for this we have also designed some nice safety hacks, what you can find by Draeger, and also electricity shock. So think about a transformator or something like this. And our typical one, what René said, is lack of oxygen.
Yeah, that's quite dangerous because a lot of substances are heavier than air and they put the oxygen away, and then you have just a toxic material there, which you can't breathe.
Yeah, and here we have the reminder also ox, X, tox. And the toxic gases, it's also, be careful, but we have later more information about this. So safe operation in confined spaces, we have talked about risk assessment from the last time, and we have also some topics more. This is what I mean with the attention triangle, and this will start, we have to go all through. This is, as example, mechanical hazards. The other one?
Yeah, the second one, for example, is electrical hazards, which come from different machines you use to work in the confined space.
And the next one is our hazmat substances, what we have to do. Some parts is when we work inside, so we bring also some hazmats inside of the confined space, and also then we change again the atmosphere.
Yeah, one another topic is a biological hazard. That's also very dangerous and comes from example from the production process, which was before we cleaned the vessel or the confined space.
And think about the bird. What the bird, as the bird was falling in, that can happen that you have to enter a confined space. Part is you have some died animals or something like this in, or in other countries can this be snakes, and this can be really dangerous.
Another point is fire and explosion. A lot of the works are welding or some fireworks. So you have also the danger that you can have an explosive atmosphere. And if you bring fire into that or electrical dangers, there could be an explosion or a bigger fire. So think about that, please.
Yes, and we have also some different parts of welding. Think about this. Welding is not welding. We have different types of welding, MIG, MEG, and so on. And we have temperature. So a lot of people forgot to look on the temperature side of a confined space. So when we, as example, we both, Thomas and René, will enter a confined space, we'll also heat up the confined space with our body temperature. So as example, we started by 20 degrees, and then in our work parts of this time, we can also rise these temperatures of the confined space. Or you cannot enter, part is the temperature is too high, and you will be in a risk of temperatures, and you have to reduce the working time. Think about, we have also for this a nice safety hack from Draeger.
And heat and workloaded, it's also very important. Now we have the summertime, it's becoming hot everywhere, and it's the same thing in the confined spaces. Also the physical effects, noise, vibration, there are a lot of them, and all of them could be dangerous for you.
Yeah, René said, this is important as example, when a hammer is or a tool is falling, and you will see this later by incidents and accidents, falling equipment as example. And this is much, much louder when it's falling in a metal surrounded confined space. And now we will go from the slide part is we need a little bit more space for the next one, 8.
The working environment conditions, like I said, heat in summer times or rain could also be very dangerous in working, because if you're thinking you have to go on a ladder down into a vessel, they could be very slicky and you're falling.
Yes, and for me was this also a nice experience, as I have given a train-the-trainer course in Beijing. We have to stop the training at the daytime and have shifted over the training at night. So part is the training gallery was also too hot, and this was a nice experience also for my trainers in this case. So then we have also number 9, ergonomics and mental workload. So this is also part of the trainings. Mental workload means in this case also, can I go in a confined space? So when I will be a claustrophobic, this is dangerous for also the other colleagues. And ergonomics is here in confined space, a really interesting part. But as you have to work in uncomfortable situations. So not standard what you have on the working bench, so you have to will be here longer times on the knees, and this can be horrible in this case. And
another point is the psychological and mental strain. So there are all these hazards here that you can see on these slides, and they come into you at the same time maybe, and that's a lot of stress you are focused, and that could be a very big danger because maybe you forgot to wear your PPE, your protective clothes, or your harness or whatever, and then maybe you fall or get hurt.
So we stop here from 10 hazmats. Part is we have more is also work processes and so on. The reason that we show this is by confined space, we have an interactive, what René said, and this is the last one. This is part of, we have an interactive to all these different hazmats, and this makes confined space so, so typical. And this is a special risk assessment, an in-depth risk assessment extra for a confined space. And this is the reason every confined space has its own risk assessment. Here is really critical when you do copy and paste. And you see, we have also put in some animals and so on. It depends in which country. Can be also snakes really, really dangerous. So as a reminder, we have here our ERIC PD. This is the standard one, but what I said, we make here a deeper and specific risk assessment. So we have by confined space also to look for every time to eliminate. So when it cannot happen, we have our confined space. And then we have the replacement and reduction of the hazmats, the substitution. And a really important thing by confined space is the isolation.
Yeah, you have to take care of the people who are working inside and to take out the hazards of the confined space so that the people are isolated and can work safely. Yeah, and one also very important point is controls, the administrative measures, for example. So make sure that there is no hazardous atmosphere in your confined space. Do your clearance measurement at first and also the continuous measurement after that.
And this is the reason that we talk about now a little bit more. For confined spaces, isolation and controls a really important one. And think about every time ventilation. And this is what some people forgot. You will see this later also in the incidents and accidents. And PPE. And this is also an important part. PPE is for every confined space individual.
Yeah.
So some guys think about fall arrest systems and said, hey, I have used this for this confined space, copy paste can be a big hazmat on the other confined space.
Yeah, think about the hazardous substances, the chemicals. You can have benzene in the one confined space or toluol in the other one. So they are different and you have to take care of different protective measurements.
Yeah, and this is for us as health and safety engineers important to understand the procedure. As example, you can have 1, 2, 3, 4 vessels. There is a video also on YouTube where he's working on the first vessel, and then they have done copy and paste. And on the last vessel was in the explosive atmosphere, and then a critical situation.
Yeah.
And
I want to focus one point. It's on the bottom on the right side, discipline.
Oh, yes.
That's very, very important for us because you can make every situation, or you can prepare every situation most safely. But if you are not disciplined and look after yourself and your neighbor and your working partner, nothing can help you. So that's very, very important to have the right discipline.
And this is what we also train by RSS.
Yeah,
Rental and Safety Services, there we train extra people for this. And discipline, yes, this is one of the important things. But this gives also some 60 seconds of safety. We have designed some things about. So then we have our safe operation. We have planning, permit, and clearance measurement. So at first we start with the planning. You can see more as one. What do you think? How many people we need for confined space? Or something? I have 2 workers. I have 1 safety guard, but this is not enough. We have a lot of people behind.
Or what is the first step? Who comes at first into the confined spaces? It's you have to think about it, and you have to prioritize your workload.
Yes, and for this we have then later also different jobs, and you have to follow the job. And the permit is written inspection, it's inspection and not maintenance. And this also some people has to learn to follow what is on the permit. And this is the reason how important is the permit, and the permit will be used. You will see this later also is a part of our incidents and accidents. When you write a permit and you don't use the permit, makes the permits no sense. No sense. So, and also planning. You can also look for this and make a planning of this, what you want to do. And in this case, you can also see, we have there some issues, and you can see this in the preparing time. And don't forget, we have seen this also on the risk assessment on the module 1. We have here also a matrix. We use a matrix by confined space. We will lift it more up. We have then a matrix 8 to 8. Mm-hmm. So that we can figure out more specific what can happen in confined space. This is here on the picture, the standard one, but this is our secret. So you see there's also a matrix, and then makes sense that all will be trained. And this is not only makes sense, this is also written by law, that everybody has to be trained before he enters in confined space.
And also one important point is train your contractors. That's very important. The contractors usually do the work on site, and they have to be trained by the hazards that they are different on every construction site. So train them.
Yes, important. Constructors is for you is not gone. So what do you do? This other people, but train these guys in the facilities. So when all will be checked, we have our yes sticker, and then we have our science as example. And a lot of people forget what you see on the angle, and then on the side you see this one. This is what I also miss on some confined spaces. Where's the wind direction? and from which side I enter and to see what wind direction we have.
Think about it. If there is a dangerous situation and you have to go to the emergency point, you have to know, where can I run? Where's the wind direction?
Exactly. So, and you have to sign where you have your confined spaces and where is only entering by permit, and block all your confined spaces. Also lock it. I've also heard from customers that they've talked about, hey, we have done a nice training, and then on the next day you get, oh, we have forgotten some tools, and we was going back again to get out of these vessel the equipment. Stupid. This is really stupid. And lock all the confined spaces.
That's a matter of seconds. For example, you can use a magnetic cross that you put on the manhole, and then it's there. That's just 2 or 3 seconds. But after that, the manhole is saved.
And one important thing, have a rescue concept. So rescue concept means every confined space has its own rescue concept. So it's not, I have a plan for a rescue and I can copy this. So every confined space has its own risk assessment. And this follows the same procedure, what we have described from the working permit. So you need here also a special one. And then we have later our permit, and also, yeah, a rescue concept is also a permit, but it's much, much bigger.
And please make sure that you have the permit available on the confined space. So have a copy in your working office, but also have one on the working place, so that the contractor or the safety personnel or whoever can make sure that the required safety things are done.
Yes, and that the externally and internally rescue chain will working together. That you have no losing time of these. You will see this also on the incident accidents side, what we mean with this topic. And then makes sense that you have later, as example, some golden rules. You will find this also on the internet about lections about confined spaces. And I think this is quite good to offer more and more safety procedures. What I said also 60 seconds of safety or TOP concepts, and also 10 rules. And this is from our colleagues from RSS, as example, 10 golden rules. No alcohol as example. We offer as example from Dräger also alcohol tests. And in this case, you can also put this in your risk assessment so that you said, hey, drug test and alcohol test. So this is then special part is dangerous work.
And from my history on different petrochemicals and oil and gas sites, also steel sites, there was a lot of alcohol and drug controls in there on the front door where you can enter the site. So that's quite normal for a lot of our customers. And I want to focus you on the first point here. You are responsible for your own safety and for the safety of others as well. So that's your duty. Make that clear for you and remember it all the time. That's the basic. If you think, no, I'm not responsible for anything here, then a dangerous situation could happen all the time. But if you think about what can happen and what can I do to prevent these, that's a good basic to work safe.
And this is also hang on this is part of Vision Zero. And this part you can see which contractor you have, and you can see how the workers work together. Yeah. And in this case, you can see how far they will be with this safety culture. And we will have later a little bit more. We have a little bit lockout, tag out. So we will see this also at the end of the presentation again, some lockout, tag out. But remember here, it's part of safety. You have spoken about isolation and control. So now with the first part, we will be quite close to the end of these. Now we have the harder part, facts. We have to talk about the accidents and incidents, statistics, and also what makes sense. I will show you on the last slide. In the miss report makes sense. Part is when we look on incidents of confined spaces, it's quite hard to find exactly where is the accident or incident. And this is the reason I prepared this from NIOSH. There I find a little bit think about different on what was happening in the confined space. We had to talk about the hazmats. As example,
Yeah.
number 3 was the hazmats or dangerous parts. And sometimes is the mistake or the diet people or the fatal counted only in hazmats or in explosive atmosphere, but I have forgotten to put this under confined space, the umbrella. This is, as example, for safety, you can monitor all the parts. So in this case, you can also see some near misses or something like this. And when you look here on this picture, you will find definitely some parts that will also be here, not okay. Look on the guy on top. He's bending a little bit to help the other one with the chemical suit. So nice, he has the equipment, but there is no attachment point. So this is the reason I think also the other colleagues have done last year the training about water arrest system. Example here in this case. So now a little bit about the report of occupational health from the US. It's a little bit older. I like this one part is this has a different view on the incidents and makes a little bit more think about what can happen. So approximately we have 2.1 million workers for confined space. And the statistic has shown that we have, in this case, it's not normal work. And special depending risk assessment for dangerous jobs activities is applied. This is what we have explained the lesson before. And here's some more findings about NIOSH and research of confined spaces. When you want to look this, here in this case is the internet link. And also NIOSH said, make a risk assessment more about rescue concept, and it's required by law. Here's the link when you want to look on these by NIOSH. And here's a little overview. And for me, was this a little bit, at the first I was looking at supervisor and I was thinking, they think this is the safety officer or the safety observer.
The most trained person on the side, maybe.
And this was to see, you see present on every time, 85% from 100. So this is a good count, but a little scary was here, 29 died supervisors. So this is a little bit strange. So then we have written CSE procedures. You see from 100, only 30%. And this is less. And then you see the last one, used the procedure, nobody. And this is what we said on the beginning. And the other one had training for confined space. You see only 15.
Yeah.
So, and you see it's required. You have to be trained. And you see rescue plan, zero. Or they said, we're fixed on other things. So then untrained rescuer died. And this is one of the dangerous things. When you have no rescue plan and somebody wants to rescue each other, he's not trained, and then he comes in a dangerous situation. And you see more than 60%. So this is 50% of these rescue was dying by this. Yeah. And this is unbelievable. And you see authorized by a supervisor was also quite close to 20%. So it's a little bit strange. And now this is the reason that we have later our clearance measurement. Here is standing 0 of tested and ventilated entry. This is what we said, how important is isolation and control. Next one is, as example, what is the reason we go to or go in confined spaces? This is maintenance. And in this case, the routine work. So when we go in confined space, in the most parts, this is maintenance.
Yeah.
Or can happen repair. And you see inspection. So you see here's also inspection, only 15%. Normally we start at first inspection, what is it? And then we can start with a repair. So you see it's only 15%. And when we see behind me in the green one, is this the objects and different ones. And there we have only 6 in this case. And you see for firefighting is quite less.
Yeah.
This is really quite less. So the main part is maintenance. And also here in this case, fatal in this case, you see atmospheric on 300 is unbelievable. And a really dangerous thing in confined space is what we talk about, the noise or the vibration is losing materials, or some equipment is falling in the confined space. And in this case can happen, some guys are working quite close to a confined space and some thing is falling in. And then I said, now a permit or something like this. I said, all fine. They go further on and to get out of these the equipment. And this means these really fatal parts. And then also others. Last one is 3. So then you see we have also toxic ones. You see H2S.
In the overview in the chart there, you can see hydrogen sulfide, H2S. It's with 77% the most dangerous toxic gas which we have in our construction sites, and it's nearly followed very close by carbon monoxide. Carbon monoxide for you in the steel industry, it's so important, and please remember that's a toxic material.
And when you want to know more, you can go back on the module 2. There you will see our other colleague. He explained more about also this topic.
Yeah.
And
other gases and not specified gases, there are always mixtures of gases. So nobody can tell them afterwards when an accident happened with toxic materials and you have a mixture, what specific kind of this mixture was responsible for this accident.
Yeah.
So, or for this fatality in the worst case. So, that's also an important point, which comes back to the permit and the discipline. When there's some breathing protection, please make sure that everything works fine and you wear it and use it.
And all will be tested and ready for use. Yeah, exactly. And we have prepared this after these slides. We have some guesses more, so we have a little bit more information about this. So a little bit text that can you look on your side. And here we have also some things about for safety, also for accidents and incidents. And 3 causes will be, as example, I didn't think.
I didn't see. And I didn't know. So what is about the training?
So this were the 3 monkeys in this case. But sure, we have to look for. And then we have the 2 types of human failure as example. And you see on one side is the error, so action error. Then we have action not as planned. And this is a really dangerous thing by confined space. So when you see it is not working as planned, stop.
Yeah, that's very important. If there comes, maybe you hear something that shouldn't be there, like a gas flow or whatever, stop your work, go outside of the confined space, ask your supervisor. Information is so important. Please remember that.
Yeah. Then we have also the action-based slip, and we have, we have the based one. Thinking error is as example. And on the orange one, you can also see on the orange one, this is what René also said, work discipline. And think about routine. You have seen this in the accidents and incidents. And we have done this for 30 years the same way. This is the typical one on the orange one. And remember to optimize these. And this is training discipline for the workers.
Yeah.
And also think about to note like a near miss report. As example, we had an emergency escape, what you explained with the gases. So they enter out of the confined space. You have to note this as an incident or as an accident to make, in this case, then a near miss report to look what we can do better next time. What was the reason for this? So, and a lot of people don't notice this is the reason we get so incorrect values of the accidents and incidents. To go here deeper in details. So now I hand over the one because we have now our gas measuring.
Yeah.
And I hand over for you and
thank you.
Change the slides.
Of course.
And
thank you, Thomas. I just want to make sure to go to the last slide with the near misses. Think about your daily work on a turnaround, not a turnaround, daily business. But this is one of the most important things that we train every customer. Near misses has to be documented and you have to learn about it. That's so important that the same mistake don't happen twice or third. Yeah, and now I like to give you some more information about gas measuring, clearance measuring, and also one very important point is monitoring. So please remember, suffocation, the absence of oxygen. It's so dangerous. Please make sure that you have enough oxygen in your confined spaces or on your working place. Another danger is done by explosions, so by flammable gases or vapors. They are measured in volume percent level, but they are also very important, not only inside of the vessel, also outside of the vessel. So maybe you have a tube or a production line which is in process and gets leakage. Then you maybe get a explosive atmosphere when the toxic material comes together with the oxygen in the air, and then you get an explosive mixture, which could be also very dangerous for the people inside of the vessel. So it's on both sides very important. And as we talked, poisoning by the toxic gases, they are measured in the ppm level. They are also very, very important. And this is just a few examples. Like I told you, the H2S is the toxic gases which is responsible for the most of the fatalities which we have on construction site, followed by carbon monoxide. That is very important for the steel industry, for your industry, and we just want to focus you on this one as well. But I also want to give you the information about ammonia, for example. It becomes more and more important, and also in the steel industry, when you're thinking about hydrogen and clean tech industry, you need, for example, ammonia or methanol or whatever as a carrier gas. And this is very, very important and will be more important in the future. And I talked about clean tech industry, the hydrogen. This is also one toxic material I want to focus you on. Okay, and let's have a look at the steel industry. Like I told, carbon monoxide. Carbon monoxide is the most important or the most happened toxic material in your construction site. And please remember, you're working with high temperatures, with a lot of mental and body stress that comes into you, and carbon monoxide is always present. So that's very important. We told you the wind direction. It's so important. If you're thinking about an escape situation, you have to know where you have to run to your escape place. And also this fire extinguisher. If there is a small fire, you can handle it with a fire extinguisher. That's very important to make sure that the fire don't become bigger and bigger and will be hazardous for other working or workers in your surrounding area. The blocking material for the confined spaces, please remember that. And nevertheless, confined space only with permission you are able to enter. Only on this day and this time period, which is given by the permission, please make sure that you are on the right day to the right time to work there. So let's think about the toxic materials. What is so important? Remember, we have gases, they are lighter than air, and also which one that are heavier than air. This is very, very important for your clearance measurement, which you have to do on a daily basis or shifting basis. So where I have to do my measurement, or should I done it on the bottom of the vessel, or maybe on the top of the vessel under the roof? That depends on the gases that are used inside. And here you can see the CO2, carbon dioxide. This is also very important, especially for small vessels and confined spaces. You bring carbon dioxide with you. If you exhale your air, then you can see here, where's my laser pointer? It's gone. So no problem. When you inhale, you have a carbon dioxide part from 0.4%, and if you exhale it, there's more than 4% in it. So remember that when you are in a very small vessel, for example, that could be dangerous as well. Okay, barriers, lockout tagout systems. They are very important, and they are one of the bases for the permission. So every worker has to make sure before he starts with the work that the lockout tagout system is on the right place, and it's set so that it's not possible for hazardous substance which come from other tubes or whatever to go inside your confined space where you want to work. Yeah, great care should be taken that all isolation systems are kept in place until all persons have exited the confined spaces. So you have to make sure everybody is out when you want to replace them in the end of the work. And now let's talk about the clearance measurement. We have different materials to do that. Like you can see here, that's one of our XRM gas measurement devices, which includes sensors. With them, you can measure the toxic or untoxic atmosphere in this vessel. Here you can see the worker, which climbs up the ladder to work inside this vessel. And very important, you have the ventilation here. We talked a few slides before that the ventilation is very important, and it's also important for the measurements. So the ventilation has to stop 30 minutes before you do your clearance measurement, that you have the right point of view and the right view inside of your atmosphere there. So these are the key points I want to focus you on. You have to make sure that you have a proper gas measurement, that this one is tested for this day. You have to make sure that you have the knowledge about the target substances. So what toxic materials could be inside my confined spaces? Are they lighter or heavier than air? Where I have to measure? And organizational settings, right place, right time, that's given by you on the permission. The lockout tagout system, it's very important. And here, the working permission. And this is one point I want to focus especially you on, is the continuous measurement. So if you have done your clearance measurement, you also have to do a continuous measurement after that to make sure that we don't have changes or new hazardous materials inside of the confined spaces. Yeah, here you can see a measurement on the confined space on different places. You have to do the measurement for every manhole. That's very important. And for that, you have to use the right material. For example, thank you, Thomas. We have the tube here, which we can use on the bottom line, for example. You can see it here on the worker. He used the right one. But if we have to do a measurement from the top of the vessel, we need something different. So therefore, we have these measurement balls that you can let down into your vessel or confined space and do the measurement inside of the confined space. With these, we can handle much more tube lengths than with this one. This is maybe 1 meter or 1.5. And with that one, we can go down up to 10, 20 meters. So that's very important. Please make sure that you use the right equipment. Yeah, and here on the left side of the screen, you can see different gas measurement devices. The right devices depends on what target substances you have. Maybe to test the oxygen, it's enough to have an XRM 8000, or like you can see here. Thank you, Thomas. But if you want to do a measurement for organic substances, maybe the X-bit is the right measurement device, because there you can have a gas chromatography inside and to do a selective measurements for your toxic materials. And after that, you know exactly what target substances I have in which concentration.
And we can also use the hoses and so on. It's
Yeah.
also with ball and so on.
You can connect the same hose which you use for the XM series on the XP80, for example. So
there's a reason we have a nice training for this called AGT, Authorized Gas Tester. So it's in the portfolio from Draeger.
Yeah.
Yeah.
So we continue our measurement portfolio. There you can see an external pump, which you can use for your XIM device. That is also possible to wear as a personal protective gas measurement device. So you can wear it all the day and also do a gas measurement, a clearance measurement with an external pump. Here we can see a fixed gas detection, which is normally installed in your construction site. And here, this is very important. You can see the line here, and we want to focus you on do your measurement on different points on the confined space. So do a measurement on the bottom of the confined space. Therefore, you need the ball with a full length, for example, and then do a second measurement a few meters higher than them, because you have to make sure that we have a clean area here and we also have a clean area here. Because if you think about, we have to work on the bottom and we also stand up and have to work on this height and also on the entry. That's also important that there are no hazardous substance on the entry. So 3 measurement step. Use the correct measurement hoses and think about that we have a pump integrated in our measurement devices or on the external pump, but it needs some more time to pump the atmosphere from the first step into your device. So this measurement will take much more time than the third measurement.
And you see, we look also on this picture, wind direction. So the wind direction can be changed, and this is how so important it is to have a technical ventilation. Natural ventilation is one of the dangerous things.
Yeah. Okay. On this one, you can see our X-zone. It's made for area monitoring. So you can measure the hazardous situation outside of the vessel and to give you some information inside of the vessel. So you have the possibility to connect them to each other and also to put them in different kind of groups if you want to. So that you can see on the picture on the right side. These X zones are connected with each other. One of them is outside of the vessel. The second one is inside. We have a third one inside, a fourth one outside, and the fifth one on the next level. And all of them are connected. So if we have a hazardous situation on the top of the vessel, we also have the alarm on the bottom because they are connected.
And the important thing by this is when we have a break, you have a continuous measurement.
Yeah.
And otherwise we have to retest again the atmosphere. And with this, it's a possibility.
Yeah. Now we have to focus a bit of the time. And this is just one point I want to show you. The lockout takeout for, it's not really a lockout takeout, but it's a block to block the confined space, the manhole, maybe for a break time, for your lunch time or whatever. Please make sure that this one is right in place, that nobody can enter the confined space without a safety guard, without a clearance measurement, or without a continuous measurement. Yeah, here we have one example with the X zone on the outside which has a tube inside of the confined space. And here we have one of the worker or gas analysts that do his clearance measurement before the working starts. Then he can write the values, the thresholds into the working permissions, give the same information to the working permission offense, that everybody is informed, right? And to give the working permission for the right day.
And they can change the informations. This is the nice guy behind us with the green helmet. You can't see this at the moment. He can also get the informations on his display.
Yeah. Yeah, this is, there you also can see the wind direction. And this is one hint we want to give you, that we are also able to do our GTC system that shows us where the people on the site are working at the moment, and what kind of values they are exposed at this moment, for example. Yeah, also another picture. This is quite educated well, because you can see the fire extinguisher on every manhole. You have the clearance measurement and the continuous measurement on every manhole. Here on the top with the right tube and the ball. And here we have also the tube and the ball inside. So that's a quite good situation. On the right side, you can see the area monitoring that makes sure that no hazardous situations come or gases come over from in construction site in the surrounding area.
And this is also what some guys forgot to use here in this case, 2 safety observers.
Yeah.
This is also what we have seen in practical.
Yeah. Also another picture. And on the last side, I just want to give you the information that we have the possibility to get a wireless connection between, if we want to measure something, we can give that directly to the working permission office, that they can do their working permission for each day. So that's time, or a factor of time that you spare some time that you have to, or that you need to go down and go back to the working office. That can be done on the digital way.
And you see, we have exactly 1 hour.
Yeah, we are right on time. So, but this shouldn't be the end. So I want to give you the opportunity. You can contact us both every time. You just have to scan the QR code here or here, and then you get our LinkedIn profile. We can connect each other and talk about your specific topics you have. So we are open all the time. Please contact us if you have some questions or ideas. We are welcome.
Or question about training, catalog,
everything.
or something like everything.
Okay.
About the topic confined spaces.
About the topic confined spaces.
We have other colleagues.
Yeah. So what is coming next? Today we are talking about the safe operation in confined spaces. We have the 4th of July today. And the next topics are maintenance works at and the last in the end of October. August. Sorry, the end of August. And in October we have the 5th topic with life insurance, mobile gas detection devices, and your life insurance.
Think about life insurance in October.
That's right. Thank you. And
well,
now
thank you.
I'd like to hand over to Bradley again, and thank you for your attention.
Thank you very much, Thomas and Renee. That was a very interesting and indeed important presentation. And as you say, the timing is perfect. So I think in this case, if people do have any questions, I would encourage them to get in contact with the guys at Draget directly using the details that they've provided. Also, if you would like to find out any additional information about the safety performance of the steel industry, you can visit the data report that we've published on worldsteel.org, as well as our position paper and other documentation on this most important topic that we're dealing with in the industry today. Thank you very much also for doing my job and letting everyone know when the next webinars are coming up. And I hope to see many of you there at the end of August. So thanks once again to Thomas and Renee. Stay safe in the meantime and see everybody soon. Thank you. Bye-bye.